Okay, my friends, everything has started over now. They have started to realize that this is valid research, and I'm going to just shoot through this, and then we're going to start the new school, and it's going to be an interactive forum. It's not going to really be a school. It's going to be a place for the exchange of ideas. Now, this is pulsed red laser. There is a particle at the tip of each one of these waves, and it creates a wave just like a jet fighter going through the atmosphere. That particle that was right here is right there, and it is a dipole. It has a dark and a black and a white side, and the white side is concussive. The dark side, it appears to be very, very strongly attractive gravitationally. Now, what happened here was we accelerated that light due to this Venturi, which is what now they're looking for, is called a muon collider, and we created this 7 or 8 years ago. And it takes the particle and forces the muons to go around and lets the electron showers come through. And when they do, they come out and slam at us as Cherenkov radiation. The particle, the wave, the acceleration, we've got a lot of trouble with physics, and we have to start over, and we are. And here's where that particle is actually literally separated. You see, remember it was that little box before? Well, it's no longer a box. The black ones can't get through. They say they're 200 times heavier than the white ones. That could be. The white ones are getting through. The black ones can't get through, but they come back and smash back in over here, spontaneously. Bing, bong, done. But no black ones can get through. This is a Venturi. This is our new collider. We've been showing this for many years now. And that does what they want. It separates the muons from the electrons and creates the showers precisely as is shown over here. Let's see what we got here. This is what they want to see. And there it is. At the black ball, when it was attached to the white ball, it stayed the same black ball. Nothing happened when it turned into the Cherenkov. But the white one exploded into the showers. Now, it appears that the black one is just only gravity. It will not explode. It will not create emissions. It will not absorb. It doesn't show. It only absorbs the white. And it doesn't absorb it. It just hangs on to it. That's all I can say. Now, a little more research needs to be done. Absolutely. Okay, I either have or I will show you that we can separate dark matter from the white particle matter. And I can literally show you what the magnetic field will look like of dark matter inside, and there it is right there. The glowy parts will be around the dark part, and that's what happens with magnets. And the magnets are nothing more than dipoles. Dipoles are nothing more than photons. Photons are nothing more than electrons. Electrons are nothing more than dipoles. And here's what happens when plasma in space. Now this is plasma, and then they injected these dust particles. They expected them to line up in strips like this. This is absolute ecology. And what happened was they created a black hole. And I sent this to Fermilab, and of course I sent it also to the Russians. I know, well, I don't really know them, but the National Academy of Sciences over there, they seem to be nice people. Anyway, I sent them, you guys, and this did this back in 2015. So, and I knew it back then too, but nobody's ever listened, and now they're finally realizing we got issues, we're going to have to deal with them. Everybody's talking about new physics now, and they have to. Now, here's what happened. They were looking for a clean lattice, but when they put the particles in there, it turned into a ball. Watch, boom, just like that. And the reason is exactly the same reason that this one's going to turn into a ball. Because the particle in the center is dark matter. And it's attracting all kinds of electrons to the outside of this, just like this is. And it's forcing the dark matter to the center. There's a lot of work to do here. This is not the end of the story, but this is the beginning. Okay, I think I mentioned I sent to the National Academy of Sciences over there in Russia that they had created that black hole in space. And I also copied Don Lincoln on it. And he sent back to me saying that is not a black hole. And he put little quotations around it like it is not. Well, I say it is. And I will make that statement very clear in my responses to what he has to say, and I'm hoping we can engage. Now, he's saying that they claim there's another form of matter called dark matter, 5 times more common than normal matter. Now, let's hear what he has to say. Here goes.
Called dark matter, that is 5 times more common than the familiar form. So what is the nature of dark matter, and how will we find it? That's an interesting question, and I think it's worth taking some time to look into it.
All right, this is Fermilab, and that's what we're going to do, take a little time to look into it. Thank you, Don. I hope we can engage, my friend. I can be extremely respectful. I just need to be able to be heard, and apparently you did hear me, and I appreciate you responding back. So let's see if we can get a little further with this. All right, if you don't know Bohr, electron flood model is not going to mean anything to you. But Bohr model says there's a gigantic nucleus which is made up of positive big chunks called protons, and then some that are neutrons, are just a tiny bit bigger, and they're neutral, but the protons have an attractive positiveness to them. Now, electron flood theory says no, absolutely incorrect. The entire nucleus is made of electrons, and an electron is nothing more than a hot particle and a not hot particle. And a not hot particle they call a muon, boson, and the hot part is the electron, the glowing part, the explosive part. Muons just walk away and never explode, and they're actually dark matter as well. Now, a photon is 2 electrons back to back in bar magnet configuration where they bounce when they hit things. Protons are 1,839 of these electrons. And because the muons have no push to shove, they only attract. So they will always go to the center, and they will always be coated by the white particles. When you turn into atoms and molecules and so forth, the bigger masses, and they will be just like a snowball like that. And all of the outside of the snowball will be the exploding part of the electron. The other part of the electron is the muon. Now let's just look at it happening. And that's why they don't understand the standard model is not just one gigantic particle, which is called a proton. This right here would be a hydrogen atom. One tiny little particle out here, which is still about a dipole. And this has got a dark matter core. Like I showed you, the dark matter will go to the core, and it will drag in more electrons. And the electrons will have this portion there trying to pull into the dark matter. However, these particles will push that white particle away in an exact distance called quantum. And here it is right here. They'll have plenty of electrons coating the core to where it says, I don't want any more electrons coming in here. And then it'll say, okay, well, this guy says, I want to come into that black matter. And I'll say, no, you have to stay at a certain distance away. I will push you. You will pull your way in. We will decide at a distance you're going to stay. And that is quantum. That's what the distance is. It's a couple of angstrom units out, and it'll try to force its way in, and it won't let it. And it's always going to be pushed to shove. And I show this in the magnet experiments and the salt experiments and the light experiments, and it is very, very obvious when you do the experiments, just like they're talking about. And we got to do the experiments. That's exactly what we did. Okay, my friends, Roger again, and I am going to just explain very quickly the new particles that they have missed that are in the subatomic range, and they are these muons, which are these extremely heavy dark particles. They don't give off anything. They just completely attract, and they're supposedly 200 times heavier than the white explosive portion. I'll show you those in a second. And they admit that they just missed it all. And hundreds of physicists gathered for this explanation of what they found with this muon G2 experiment. But the data blew them away because it didn't account for all kinds of things. It says, despite the remarkable success in explaining, basic particles and forces that make up the universe, standard model description remains woefully incomplete. And it's because of these tiny particles. It does not account for gravity, which is the black ball I will show you. That's one thing. It's similarly silent about the nature of dark matter, which I will show you is also that same particle gravity, the black ball. dark energy, which is also that same particle because it's so energetically attractive, and the neutrino masses, which are, one of them is the black and one of them is the white. To explain these phenomena and more, researchers have been hunting for new physics, and I have shown them these, and I will again today. Physics beyond the standard model, looking for anomalies and experimental results which diverge from theoretical predictions. Well, my theoretical predictions, they don't diverge from, because I understand the nucleus is nothing more than a ball of electrons, each one of these being a dipole, not a singular huge proton. And every proton basically is combined of 1,839 tiny electrons. This would be one hydrogen of 1,839 or 40 electrons, and this would be one more that would want to get in, but the dark matter inside is so attractive that it tries to pull it, but the white matter that is not as attractive is out there pushing it away, so they end up staying at a distance called a quantum distance from the nucleus. This pushes, this pulls, it will always stay from everybody else that certain distance. And every single atom, every single molecule is completely coated with the white particles, which are the electron pusher, the exploder. The muons are the black central gravitational core, and they make the center of all particles, and they are completely coated with these electrons. So we've never seen the dark matter, it just resides inside the particles we see as explosive. Okay, well, everybody that knows me knows I've been showing that the Venturi is the way to create this new particle collider. See, this needed tool now to reveal the nature of these muons may be a new collider. Exactly. Something many physicists are clamoring for via proposals such as the International Linear Collider and High Luminosity LHC. In the past few months, interest has surged around a muon collider, which is exactly what we did. A muon collider forces them to come out and around, which I'll show you again in a second. Multiple papers predict what guarantee physicists the ability to determine the properties of the unknown particle or force affecting that muon. Now let's just look at it one more time. Now don't forget, this is CERN and this is Fermilab. They say a muon neutrino just stays the same. A muon is the same as it when it comes in, when it concusses into Cherenkov radiation. When an electron neutrino, which is the white ball, that's a black ball. When a white ball comes in, it concusses into Cherenkov and throws showers, which is precisely what I showed you. And it is when the photon, which is a particle that looks just like this, explodes at the Venturi, which is our muon collider. And the muons separate and go their separate way as the electron showers go straight through, just exactly what I showed you before. That is what we just saw right there. That's what's coming out is the black ball, and here it is, just to be sure that you can fully understand it, because it's not completely obvious there. Here it is here. There's the collider. So this is our muon collider. The muons can't get through there, so they're so massive. They're 400 times more massive than the electrons. This is basically why the muons can't get through. So you have to tune the Venturi to a certain frequency or resonance distance or whatever you want to call it that does not allow the muons to come through. They spit out, come around, but they smack right back into these white ones. Now, in this general area here, I think we have an enormous amount of energy, because if it's not glowing here and it's glowing like hell there, well, to me, that's an increase in energy. And we know that they're separated. There's no question whatsoever. There's no black balls whatsoever here. And then they come back in as an attachment, a magnetic attachment, basically. I don't see any big difference in size. These are the black particles, you see them? And these are the white ones. Now, are the white ones a tiny little dot in the center glowing outward? It would seem that they don't fill this space. Does the dark matter completely fill the space, and the white, let's call it white matter, doesn't fill the space? It's like a balloon, and it can do this, but it's really not filled that space, and this is almost like a solid dense mass, 200 times thicker in the soup content than that one. I mean, this appears to me like it might be just a spongy ball, and this is not so spongy. I don't know. They look the same, but we definitely can see the black will not go through that venturi, and the white does. Okay, I've been presenting this for years now, and I think they're finally going to start to talk about the things that I've shown. It says even those who are skeptical about the significance of these new results cannot help but find a silver lining. It is good for particle physics, Dorio says, because particle physics has been dead for a little while now. No, it hasn't. It's been dead for a very long time. Bohr was wrong. Everybody's had to build their model about the Bohr model and Einstein and Hubble and all that, and that's not a single word of it has been correct. Until you get into electron flood theory, you don't understand the nucleus. If you don't understand the nucleus, from there it's just all sort of guessing around. That's why gravity is such a mystery. All right, I'm not going to try to confuse you too much here. All you're looking at is a pulsed red laser. So there's a little tiny particle right here forcing its way through, and it has a magnetic field surrounding it. So all of the particles out here get concussed as they have to get out of the way, so they start to glow. This is the big glower. Now, what happened here? Why is this look like it's accelerated? Well, it did accelerate, which means light can accelerate, which means Einstein was not correct. And the particle is right there, and the particle now has been accelerated and it's pulled itself out from its wave into a concussion at the venturi, which literally created a separation of powers. And I'll show you, because originally there was a box of particles just like this. And when it hit the venturi, all bets were off. She exploded. Just so you can see the progression of the increase in explosive value of the particle. Coming in, you wouldn't even see this until it starts to stack up. And it starts to stack up here, and then they become black and white. Then it becomes a box of particles. Then it becomes have spikes up and down. And then they explode at the venturi, and they literally separate from each other. All right, you saw the light accelerated, and you saw, as I showed you, they come in, and then the box displays, and then here the box explodes. And what do you end up with? Black balls and white showers. That is exactly what CERN says is what we're looking for. Let me show you. All right, this is the particles I showed you. They were coming in, and then they exploded. So we have one electron here and another electron here, just like two-bar magnets. These are the attractive portions. That's gravity, dark matter, muons, bosons, carriers, whatever you want to call them. These are the only thing we ever knew existed, which was particles that could concuss and could illuminate. That's what matter is to us. Well, this is not concussive, it's not illuminating, it will not absorb, it will not attract, it attracts. That's all it does. And these are the black particles. This one's concussing more because it's forward. Now, let's look a little deeper at that. But again, these are the two nature of particles. One of them is a dark attractor, gravity, and the other one is an exploder, the white ones. All right, so we know we have one that doesn't explode, and we know we have an exploder. So these are basically the muons and the dark matter. And this is the white matter, the white showers. And here's exactly what CERN says. Exactly what, I'm not making anything up. This is not my words. A muon neutrino and an electron neutrino, the black ball and the white ball coming in. When they smash, the muon just stays the black ball, and the white ball turns into electron showers. There's not a big mystery here. It's just that we were the only ones that ever did it to can show it. And then they say, oh, you can't see it because you can't see down into that range. Well, you can when you have extreme, intense luminosity from the concussion. You can't see an atomic bomb from 10 miles away until it goes off, and then you can't miss it. Same thing here. By the way, just so you understand, this is nuclear atomic photonic fission. We divided the black and the white particles. That's fission. And this is in the photonic realm, which is below atomic. Now, atomic fission, you end up with gigantic chunks of things. In photonic fission, you end up with smaller particles than actually the complete light particle. You end up with little tiny bits of those pieces. That's atomic fission on a desktop. And that, my friend, is an increase in value of the energetic particle approximately 200 times. If we had just harvested right there before it recombines, send it down like a gutter, right down into a drain, and drain it into something that's going to absorb it and charge. And you could charge your car probably in less than a minute or so with something like this, because you're not just pushing particles, you're pushing electrons, and they're going to hook up just as quick as they can. They're going to grab every dark particle they can find instantaneously. So the bigger the bucket, the faster it's just zip, boom, done, case closed. All right, basically it's what they call Gibbs free energy. And here's the pulse red laser. We could use red, blue, green, whatever. He shoots the particle out into the venturi. The venturi captures the active particles, brings them down in storage somehow. It's simple as that. It's very almost, you need some capacitor, filter, regulator, that type of stuff, diodes and things, and the solar collector. And you may need to put a Tesla coil or a Van de Graaff generator, or both in there. And the Tesla coil will add extra electrons. The Van de Graaff generator can make it push or pull electrons. So a few little devices, but I'm talking about very, very simple. What you could do right there could put in a shoebox, could run a house very easily. And with nothing else attached, you just go out in the woods and plug it into a house. Have a nice day. Okay, they're saying they don't understand how distant galaxies distort and all these twists and why it congeals the matter in the center. I can show you quite easily. What it is it is nothing but space filled with particles. So as this spins forward, it's smashing its particles into these particles, forcing it to twist in. When it twists in, instead of this just spinning freely, it starts to crush its center. Now it doesn't. Now it crushes more and more. Now the harder it spins, the more it crushes. And that's exactly what a black hole is. And a supermassive black hole just means that there's more and more wrench going on, pushing these particles back, crushing this in the center, just like I showed you here. Crushing back, and it forces this. This is a pipe wrench. You put it on a pipe, you pull it this way against it, and it crushes what's in here. If you had a tin can in there, you could actually crush it. And that's what happens there. And when it does, all the dark matter now is getting closer and closer and closer. Already, it appears that it's much heavier. I can't prove that, but it appears to be, it could be 4 times more heavy than what looks like white particles, which is the other side of the electron. Because the electron is the black and the white. I've shown it 1,000,000 times, and we're going to talk about this in very, very deep detail because it needs to be talked about. And that's what the school's going to be. Now, by the way, let me just show you this. Here's what we're going to be doing. I'm going to call it, I believe it's going to be called World Forum University, or World Forum something. Discussion and interaction. That's what we need, discussion and interaction. Because right now, Fermilab is putting out something, and Sabine Hochstenfelder is putting out something, and somebody else is putting out something, and I'm putting out something, and everybody can ignore each other, but these are the guys that get the press because they're the big guys. Now, we're going to confront them with this school, and not confront in a nasty way, but we're going to engage. Let's go with that now, and we're going to have solutions to things, not just complaining. I'm a complainer, yeah, absolutely, but I complain about things that I have solutions for, and they're not being allowed. I resolve things. I'm a fixer. We do experiments. When we want to figure something out, we test it. We do randomly controlled tests. We do tests and sampling and surveys and questionnaires. And we get positive results. And at some point, not right away, but at some point we will be able to issue certification that you understood the concepts. Now, whether or not you care if they're true or not, that's up to you. But because we're going to go into a lot, every single thing there was has to be re-evaluated based on the mud fossils for sure. If a goose head can turn into a rock, and it does, and I have giant human beings that are DNA certified, this is just the tip of the iceberg. It all has been denied. Bones can turn into stones. All right? And I mean, I've got them DNA certified. I got blood coming out of them. So, and I've been presenting this for many years now, so there's no questions whatsoever. I am the one that has the evidence. I am the one that needs to be addressed. And that's what I'm expecting. So stay with me, because if you go to school now and paying for it, you're making a big mistake. As you will see if you stick around, and we're going to have this daily, probably. I'm hoping for that. What I want to do is basically like a classroom daily, where we interact so that we're digging through this stuff together, and people say, oh, what about that, what about this, and I have this to show and I have that to show. Well, yeah, we could probably do that. And I don't want to be the main focus of everything. I want to present things and say, well, let's dig into this. And then that's what we'll do. Now, there may have to be some monetary involvement here. Now, not for me. I don't care about money. Is not whatsoever what I need. I don't need any. I'm not rich, but I'm a cheap date. But the guy that I want to do this may need a little assistance because, everything costs things. And he's going to be putting a lot of time into this. I expect to put a lot of time in myself, but my time has no value. He's got to make a living. He's got kids. And, he's got things. He's got a regular life, which has gone long ago for me. So I just want this to be. I'm just having a good time doing it. Let's put it that way. That's all I care about. Let's go with that. All right. So let's get started.